Now, in its 25th year, its silver anniversary, the Philippine Mathematical Olympiad is going back on site in various test centers across the country after 2 years of online competitions. After its trial run in 1984, it was officially launched in 1986 and has been held annually since 2007. The country's contestants to the International Mathematical Olympiad are chosen from the top students who compete in the Philippine Mathematical Olympiad. The PMO is a project of the Mathematical Society of the Philippines and the Department of Science and Technology Science Education Institute, with official airline partner Cebu Pacific, and major sponsor Foundation for Upgrading the Standard of Education Incorporated.
Good day. My name is Immanuel Balete, a former PMO contestant. Welcome to the PMO video series. Today, we will be talking about the binomial theorem. What is a binomial? Simply put, a binomial is an expression with two terms. For example, x plus y is a binomial because there are two terms x and y. The binomial theorem is concerned with the powers of binomials. If we start with x plus y raised to 1, then that simply evaluates to x plus y. If we expand x plus y squared, then as most of us are familiar with, we will get x squared plus 2xy plus y squared. If we go on to x plus y cubed, some of us may be familiar with this formula. If not, we can also solve this as x squared plus 2xy plus y squared times x plus y, and then expand. And we should get x cubed plus 3x squared y plus 3xy squared plus y cubed. Now, if we go up again to x plus y raised to 4, hello, my name is Immanuel Balete, and I am a former PMO contestant. Welcome to the PMO video series. Today, we'll be talking about areas of triangles. Let's say we have a triangle ABC. We'll be using this notation of square brackets to denote the area of triangle ABC. Here we have a very familiar formula. The area of triangle ABC can be found as 1/2 base times height. So for example, if in this diagram, if your base is AC, if we set our base to be AC, the corresponding height would be BD. So this is the very familiar formula for most of us. But what do we do if we don't know the height of the triangle? What if we don't know the height? And what if we know the side length BC, which we'll call A, and the side length B, which will the side length AC, which we'll call B, and we know this angle, the angle at point C. It turns out by using trigonometry, we can still use 1/2 or 1/2 base times height formula. We can still use it by solving for BD. Okay, in particular, we'll be examining this right triangle here, triangle BDC. And if we recall from trigonometry, the sine of angle C is equal to opposite. The opposite side is BD divided by the hypotenuse, which is BC. And we set BC to be A. So this is BD divided by A. And now we can solve for BD. So BD is equal to A sine times sine C. And substituting this, if we substitute this into our formula for the area, we get a new formula, which is the area is equal to 1/2 times B times A sine C, or 1/2 AB sine C. So this is our new formula. We here, as we have here, we can also solve for the area of a triangle by using 1/2 AB times sine C. Now be careful because remember that the if we have these two sides, the angle that we need should be the angle between the two sides. If we're given a different angle, for example, if we know those two sides and we know the angle at B, we cannot apply this formula because it needs to be the angle between the two sides specifically. Now, let's see how we can use this theorem to solve a problem from the 25th PMO qualifying stage. Number 2. Let O and A be those defined points. So O is at 0, 0, and A is at 0, 1. Suppose a point B is chosen uniformly at random on the circle x squared plus y squared equals 1. What is the probability that the triangle formed will have an area of at least 1/4? I encourage you to pause the video here and take a few moments to try to answer this problem on your own. All right, let's look at the solution for this problem. First, we need to draw the diagram. So we've already drawn O and A here on our Cartesian plane. The circle, if we recall the graph of this circle, it is a circle centered at O, and it has an area, has a radius, has a radius of 1. So we have this circle with a radius of 1. And we want to choose B somewhere on this circle. Let's say we put B here. We want to know what the area of this triangle will be. Triangle OAB. And we can't use our usual formula 1/2 base times height because we don't know any of the heights. But we can use the new formula we learned, which is 1/2 OA times OB times the sine of the angle between them, which is AOB. So the angle between them is this one, between OA and OB. And why do we want to use this formula? We can use this formula because OA and OB, we know that they are both equal to 1. They're equal to 1 because they're on the circle. And remember, the circle has a radius of 1. So we know for sure wherever B is, no matter where you choose B, OB is always going to be 1. Now we can simplify the area to be 1/2 sine of angle AOB. And let's call that angle theta. Let's say that angle AOB is theta. Therefore, the area of your triangle is just 1/2 sine theta. And we want this to be at least 1/4. Or in other words, we want to find the value of theta such that sine theta is greater than or equal to 1/2. Let's focus first on the right side of the figure. So let's say that we choose B to be on the right side of the circle. Now we'll ignore this part. Let's say B is on the right side. So theta will now range from 0 degrees to 180 degrees. Okay, so how do we find theta? One way we could find theta is to observe the graph of the graph of sine theta. So let's say this is theta and this is sine theta. The graph will look somewhat like this. where this is 360 degrees. This point is 180 degrees. This point is 0 degrees. And 1/2 will be over here. 1/2. So to get a value greater than 1/2, we need to be in, we need this, we're interested in this portion where it's greater than 1/2, greater than or equal to 1/2. And we need to know, we find that theta needs to be between two angles. What are these two angles? We need to, let's say it's alpha and beta. We know that sine alpha is equal to 1/2 as well as sine beta. And in order for sine theta to be greater than 1/2, we need theta to be between those two angles. Okay, but what's alpha and beta? If we recall from our special angles, alpha will be 30 degrees, while beta will be 150 degrees. Therefore, theta needs to be between 30 and 150 in order to satisfy the problem. If we draw this on our diagram, what will that look like? Okay, so let's erase this. Oops, sorry. Let's erase this. So the point B needs to, the angle formed by AOB needs to be between 30 to 150. So that would be, could be here. And 150 would be over here. So if you, this one would be 30. And this angle in between, the angle in between will be 120. And so we find that B, the point B, needs to be on this arc. B needs to be on this arc. As long as B is on that arc, we know that the area will be at least 1/4. Great. And what about the other side? Remember, there's still the other half of the circle. Well, the situation is exactly the same because it's symmetric about the y-axis. So on the other side, B just needs to be on that arc as well, on the reflected arc. So that's also a measure of 120 degrees. All right, but what's the question want? The question is asking for the probability. And to get the probability, we note that the total measure of all the arcs, the total measure of all the arcs where we can choose B will be 240 degrees. And then we divide that by the total. So the desired parts are 240 degrees, but the total is 360. So your probability is 2/3. And that's letter D. Great. Now let's look at another formula that we can use to compute for the area of the triangle. Let's say you don't know any of the heights. You don't know any heights. You don't know any angles, but you do know the 3 side lengths of the triangle. If this is all we know, can we get the area of the triangle? And the answer is apparently yes, we can. We can use this theorem called Heron's Formula, which states that if you have side lengths of A, B, and C, the area of the triangle will be the square root of this long expression, S times S minus A times S minus B times S minus C, where S is equal to A plus B plus C all over 2. This is what we also call the semi-perimeter because it is 1/2 of the perimeter. So S stands for the semi-perimeter. And to better understand this formula, let's try to use it on this example triangle with side lengths 5, 6, and 7. Again, we first need to get the semi-perimeter, which is 5 plus 6 plus 7 all over 2, or 9. And now that we have the semi-perimeter, we can simply substitute into the formula. So the area will be the square root of 9 times 9 minus 5 times 9 minus 6 times 9 minus 7, and simplify, 9 times 4 times 3 times 2. And if you simplify, you should get that the area is 6 square root of 6. And that's it. It's a very convenient formula. You don't need to solve for any angles or any heights. As long as you know the 3 side lengths, you can immediately get the area using Heron's formula. Great. Now we'll try to use this to solve another problem from the 25th PMO qualifying stage. Again, please pause the video to try out the problem on your own and then come back when you're ready to hear the solution. Okay, so in triangle ABC, first let's draw the diagram. We have triangle ABC, and we choose point D on side BC such that BD is to BC equals 1:3. So let's say BD is equal to X. Then what would DC? What's the length of DC? It's not 3X, be careful. It's not 3X because it's BD is to BC, not BD is to DC. So DC should actually be 2X because you want the entire BC to be 3X. Okay, and we're given a few lengths. So AB is 4, AC is 5, and AD is 3. Find the area of triangle ABD. We can kind of see why we want to use Heron's formula here. We already have 2 lengths, and we have some information on the third length. We just need to find X. And how do we find X? To find X, we will use another theorem called Stewart's theorem. If you've already forgotten about this, or you need a quick review, please check out the PMO video series number 5 by Isam Wang, where he explains how to use Stewart's theorem. The mnemonic for Stewart's theorem is, or one mnemonic is the man plus dad equals bomb plus sink. And what do these letters correspond to in the figure? We can set this to be M. No, so we can set this length to be M. This length is N. This length will be D. And ABC are just your usual ABC. So A is opposite, or well, for this labeling, A is this one, B is this length, and C is this length. Okay, it's a bit of a lot to take in, but once you get used to Stewart's theorem, it's very helpful. So substituting these lengths into the equation, we'll get X times 3X times 2X plus 3 times 3X times 3 equals 5 times x times 5 plus 4 times 2x times 4. I'll leave this as an exercise for you. Try to simplify this equation and solve for x. You should get that x will be equal to the square root of 5. Great. Now that we know x, we have all the side lengths of triangle ABD. And we can now apply Heron's formula to find the area. So first, let's redraw the diagram. We only want to focus on triangle ABD. And we know that AB is 4, AD is 3, and thanks to Stewart's theorem, we know that BD is 5. Now, recall that the statement for Heron's formula is square root of S times S minus A times S minus B times S minus C. S is our semi-perimeter, so S is equal to 4 plus 3 plus square root of 5 all over 2, or square root of 5 plus 7 all over 2. And we just need to substitute now into the formula. It looks a bit scary because do we really want to substitute this in there? But don't worry. I'll show you how to carefully if we multiply the terms in a careful order, it will not turn out so bad. So now we have the square root of, we'll just substitute all of our, we'll substitute A, B, C, and S into the formula, and we should get this expression. And if we simplify each of those fractions, we'll get this one, it stays the same. Square root of 5 minus 1 over 2. Square root of 5 plus 1 over 2. And negative square root of 5 plus 7 all over 2. Before we continue multiplying, you might notice that some of these terms look quite similar. For example, the two terms in the middle, they only differ by one sign. And similarly, the two terms at the end only differ by one sign. And what does this tell us? This tells us that we can use the difference. This is the difference of two squares. So if we multiply the terms underlined in blue first, that gives us square root of 5 squared minus 1 squared all over 4 times the terms underlined in green, 7 squared minus square root of 5 squared all over 4. And now this is a lot easier to work with. We can simplify the first fraction to be 5 minus 1 over 4 times, the second one will be 49 minus 5 all over 4, which simplifies to square root of 11. And thus, our answer to this problem is letter B, the square root of 11. And that's all for this video. I hope you learned a lot. Remember, we have two new ways of finding the area, which are 1/2 AB sine C and Heron's formula. That's all, and thank you for watching.